In the last section of this book, we look at the lithosphere, or the actual crust of the Earth, or the Earth portion of our environment. And I know when you took your pre-AP exam this last Saturday or Saturdays ago, the first couple questions gave you a picture, something similar to this, and they pointed out different points on this map and asked you what type of plate tectonic movement was going on. Here, if we took a pie cut out of the Earth, you could see the different layers. Here at the top of the crust that we interact with is called the lithosphere. Then under that, we have the mantle. And the mantle determines how the lithosphere moves. And below that, we have the outer core and the inner core. So how the mantle down here determines the lithosphere is because of the convection currents that's going on inside the mantle. So here we have uneven heating as well. We have warmer temperatures here, very extreme temperatures here, and cooler temperatures up here. So as this magma, which is in the mantle, heats up down below from these warmer from the outer core, this material rises. Because when things heat up, they tend to rise. And they rise to a point where they hit the crust or the lithosphere of the Earth, and they either are going to try to escape outwards, or they get trapped under the lithosphere and move in a direction where they eventually cool, and as they cool, they condense and drop. So this convection current in the mantle causes the lithosphere to move in different directions. So that's what gives us our plate tectonics and the movements of our plates, is this uneven heating within the mantle and the convection currents within the mantle. Main features of plate tectonics: the Earth's surface is covered by a series of crustal plates, which we'll see here in a second. Ocean floors are continuously moving, spreading from the center, sinking to the edges, and being regenerated. Convection currents beneath the plates move the crustal plates in different direction, and the source of heat is driving the convection currents is radioactivity deep in the Earth's mantle. So first type of plate movement we're going to look at is divergent. And divergent plate boundaries is where plates move away from each other. And we got an example here looking at the African Great Valley Rift. This portion of Africa here is actually moving away from the main continent, and it's causing this huge valley to occur. And slowly over time, this whole area is going to be pulled away, and this area will fill in with ocean. Next type we have is looking at convergent plate boundaries, and convergent is where they converge together. An example that we have here is the Indian plate moving in with the Asian plate. And India has been converging with the Asian plate so drastically that it's causing the Himalayan mountains to increase their height and their elevation year after year. And I believe they increase something like a foot a year or something drastic. And that's big when you talk about plates moving, because they move very slow. But that convergent plate boundaries is driving the Indian plate into the Asian plate, causing this mountain range to increase in its elevation. Last but not least, the San Andreas Fault. And which kind of plate movement do you think this is? Yeah, this is transforming or transformation. That's an A, transforming. And what transforming is where these plates actually move or grind up on each other. So this plate here, the Pacific plate, is moving north, where the North American plate is moving south. And as they move, they cause friction between each other, which that friction can cause earthquakes. Looking at it here, so this portion of California and a little bit of Mexico is moving north. So eventually that could be part of Oregon up here, whereas this plate is moving south. And anytime you're at this ridge or this section where the two plates interact, that's where earthquakes tend to occur. So looking at an overview of the entire Earth and the different plates and plates movements, you can see, and they're represented here. Let me pick a color. I'm going to pick red. Solid lines, like you see here, represent convergent, where these dotted lines represent divergent, and these very thin lines represent transform. So I'm going to put a couple places here. We've got here where convergent is happening. We have here divergent, divergent, convergent, convergent, transform, transform, convergent. And when you get this convergent happens, one denser plate subducts under the other. And when that occurs, you get these little red dots represented here. And these are volcanoes. So when you have a lot of volcanoes in an area, it usually represents that one plate is converging under another. And this area here is called the Ring of Fire because it has so many volcanoes. We also have this other thing called hotspots. And hotspots is where you have this accumulation of this warm magma building up and eventually finds a way to seep through the lithosphere and come out. And when it comes out and it cools, it starts to build up land. And this usually is what forms small little island chains out in the middle of the ocean. So as my lithosphere is moving this direction, this hotspot staying the same, that is the reason why you have islands in a chain. Because these islands are older, where the hotspot used to be, because this plate's moving, and now these islands are newer and forming from this hotspot. And over time, these islands will eventually be over here. And last but not least, looking at the main type of rocks. We have sedimentary, igneous, and metamorphic. Sedimentary formed by compressed sediments, example sandstone. Igneous forms from molten magma that results in plate subduction. And metamorphic, meta, big, morphic, change, are the type of rocks that are subject to heat and pressure that undergo physical and chemical changes. Here we have sedimentary rock, which makes up 75% of all rocks on Earth, and it's also where fossils are formed. Here I got a picture of the Grand Canyon, and you can see the different layers of sediment in here. And how they're formed is as the layers above compact on top to form the layers below. Igneous rock, formed from subduction zone. If it makes out of the ground in volcanic eruption, it's called extrusive. Basalt is an example, and obsidian is an example. If it stays buried, it's called intrusive, like granite. So here you can see how igneous rock is formed as this movement of magma rushes out. If it stays inside, it's called granite, or intrusive. If it comes out, it's called extrusive, I believe. And basalt and obsidian are examples of those. Here you can see sedimentary rocks. Showing some example, granite and basalt. Types of igneous rocks. Last we got metamorphic. Meta, big, morphic, change. Sedimentary or igneous rock are subject to great pressure and temperature over time. The original rock is morphed or changed into something new. Marble is a result of this. Also, schist is a morphed form of basalt. Schist. Granite, or marble. Sorry, so metamorphic is over time and pressure how sedimentary and igneous rock change. So bringing it all together, you can see the rock cycle and how different factors can cause different types of rocks. Like we've got igneous rocks forming here, and over time as this settles and as it brings up more and new material here, that sedimentary rock, or that cools and condenses and it builds sediment. And as time and pressure and heat can change those by metamorphic into metamorphic rock. It's representing as this material here comes up, and as it continuously comes up, it builds new layers, therefore building the sediments. And over time, those sediments become lower and lower because new material builds on top of it. As they're lower and lower, time, heat, and pressure can cause metamorphic changes. That is the end of Chapter 1.